You hear AI, machine learning, and deep learning used interchangeably, but they are not the same thing. The key to telling them apart is a surprising fact. Some of the most famous AIs in history couldn't learn at all. Think of IBM's Deep Blue, the computer that beat the world chess champion. It didn't learn, it was programmed. This was pure artificial intelligence, mimicking human logic but without learning from any new experience. How did we get from that to self-driving cars? We'll map the hierarchy, find the key differences, and see real examples. To get this right, you need the proper map. These concepts aren't equals, they're like a set of nesting dolls. Artificial intelligence is the biggest doll. The broad idea of machines that simulate human thought in any way, from Deep Blue to a smart thermostat. Inside AI is machine learning. Instead of programming explicit rules, we give the machine data and let it find the patterns for itself. And inside, ML is deep learning, a specialized method using complex, brain-inspired structures called neural networks to learn from vast data. These ideas have a history. The field of artificial intelligence was formally born at the 1956 Dartmouth Conference. But progress stalled. The field went through AI winters, periods of lost funding. ML and DL brought on the current boom. So we know DL is a type of ML, but what is the actual difference in how they work? It boils down to one specific, often manual process. In traditional machine learning, a person must perform feature engineering. To spot a car, you tell it what matters: wheels, windows, headlights. This manual process is time-consuming and needs domain expertise. If a new type of car appears, the features might need to be redefined by hand. This is where deep learning is different. It performs automatic feature extraction. You just feed it raw images, and the network learns what's important. The deep refers to its many network layers. Early layers learn simple features like edges. Deeper layers combine those to see wheels and windows. So the main shift is from human-guided feature selection in ML to automatic, layered feature learning in DL. This is why DL handles complex data. Let's make this concrete. Where do you see these in daily life? Simple rule-based AI is still in video game enemies that follow a set path. You use machine learning constantly. Your spam filter learns what you mark as junk. Netflix suggestions learn from your viewing history. Deep learning powers the newest tech you see. Voice assistants like Siri and Alexa use it to understand what you say. The generative AI creating images from text? That's deep learning. The vision systems in self-driving cars? Also deep learning. Do you see the pattern? As problems shift from structured data to complex patterns in unstructured data, we move from AI to ML, then to DL. But this power isn't free. Deep learning has two enormous requirements you need to know about: data and computational power. An ML model might work with thousands of data points, but a DL model often needs millions. It also needs heavy hardware like GPUs to train. There's another trade-off: interpretability. ML models are often simpler. We can look inside and understand why they make certain decisions. But a DL model with millions of connections is a black box. It gives a highly accurate answer, but we can't easily see how it got there. This presents a dilemma. Do you choose the high accuracy of an opaque system or the transparency of a simpler, less powerful one? Let's connect everything we've covered, from the very first fact about non-learning AI to this black box problem. Remember Deep Blue, the chess AI that couldn't learn? Its strength was that it was totally predictable. Humans wrote every rule. It was the opposite of a black box. The progression from rule-based AI through ML to DL is a story of handing control to the machine. We traded direct instruction for autonomous learning. Put simply, rule-based AI is a calculator. Machine learning is a student doing practice problems. Deep learning is a genius deriving calculus on its own. So, AI is the big dream of smart machines. Machine learning is a way to do it by learning from data, and deep learning is a potent technique for that learning. Knowing this difference isn't just trivia. It helps you separate marketing hype from a genuine breakthrough and see the trade-offs behind the tech. Now, when you hear these terms, you won't just hear buzzwords. You will understand the specific tool being used and the unique power it brings. The better you understand the architecture, the more effectively you can navigate the reality of an AI-driven world.